Welcome to Coding Math. This is Q&A video number 1. I decided it might be nice to do an occasional video where I just answer questions that people have while watching other videos. I don't think I'll do these on a regular schedule, just as needed. Now there was a question on episode number 2 that I think definitely deserves an in-depth answer. Basically, I drew a triangle like this and said if this angle is 30 degrees and the hypotenuse is 1, you'll find that the opposite side is always half the length of the hypotenuse, or 0.5 in this case. So the question is, how do I know this? Did I measure? Did I observe? Did I look it up somewhere? Is this just something you're supposed to know? Well, actually, it's a bit of all of those. So initially, when people were first coming up with these trigonometric relationships, they probably just drew triangles and measured them. If you were to draw a triangle like this, but far more accurately, so that this angle was exactly 90 degrees and this angle was exactly 30 degrees, and say this side here was exactly 1 meter long, you could then measure this side and see that it really would measure exactly 1/2 a meter. So you could write that down. Sine of 30 equals 0.5. Then you could draw another triangle with this angle being 31 degrees and keeping the hypotenuse at 1 meter. You could measure this side and see that it was about 0.515 meters. And if you drew more triangles with angles from 0 to 360 degrees and measured the ratio each time, you'd have a nice chart of all the sine values. Then you could do the same for cosine and tangent. It would take some work, but when you were done, you'd have a nice, useful reference. So hundreds, maybe even a couple thousands of years, these types of tables were how people solved trig problems. In fact, when I was a kid, you knew it was coming to that, right? Anyway, when I was a kid, your trigonometry textbook actually had pages and pages of these tables like that in the back. I'm not sure if they still have them or not, but when you needed to work out a trig problem, you'd have to flip to the back of the book, look up the trig function and the angle, find the value, and use that in your calculation. And we loved it. Well, maybe not so much, but that's how we did it. Anyway, here's a trig table, and you can look down the sine column to 30 degrees, and sure enough, it says 0.5000. Now, these days, you'd more likely use a scientific calculator, either a physical calculator or a scientific calculator application on your computer or mobile device. You can even use the built-in calculator on your computer. So here's the Windows 8 calculator. You can go into the View menu here and switch to Scientific, and now you have all your trig functions. You find a nearly identical calculator on the Mac and most Linux distros as well, and you can get a scientific calculator app for iOS, Android, or other mobile platforms. Now notice that this is set to degrees, which is what we want right now. You can switch it to radians if that's what you're using. It also has grads, which is another way of measuring angles that you'll probably never use. So we'll make sure that we're on degrees, and we'll enter 30 and click on the sine key, and that tells us that the sine of 30 degrees is 0.5. Finally, we can do this with code. I'm not even going to make a HTML5 document here. I'm just going to use the developer console in Chrome. So I can just open up any page, and in Windows do Control-Shift-J to open up the console, and I can just enter JavaScript right here. Now remember that in code, the math functions use radians, so we'll have to convert. So we can create a variable called degrees and set that to 30. Now this says undefined. That just means that this statement is undefined. We actually have set the degrees variable to 30. Now we can make a radians variable and do the conversion. Say radians equal degrees times math pi divided by 180. And we can test this and enter degrees and see that that is 30. And we can enter radians and see what that is. And now we can just say math sine radians. And sure enough, that is 0.5. So everyone's in agreement. Now the other part of the question was, is this just something that I'm supposed to know? Well, yes and no. As a programmer, no one's expecting you to memorize any trigonometric values. You just need to know how to write the code that's going to generate the right results. But if you were taking a trig course, there are certain triangles that you're absolutely expected to know, memorize, and be able to draw on command. One of them is this 30, 60, 90 triangle that we keep using. It's usually presented like this, with the hypotenuse having a length of 2, the side opposite to 30 degrees being 1, and the final side square root of 3. But if you divided each side by 2, you would have 1 here, this side would be 0.5, and the square root of 3 divided by 2 being 0.866, which is what we were using in all the examples so far. Another triangle that you'd be expected to memorize would be the 45-45-90 triangle, which would have the hypotenuse at the square root of 2 and the other two legs at 1. Now again, I'm not saying you need to memorize these triangles, but it certainly wouldn't hurt your overall understanding to understand these particular ones very thoroughly. Anyway, I hope that clarifies things a bit and explains why I used the triangles that I used in the examples and how I knew that those values were what they were. So if you have any other questions, feel free to ask them, and I may do separate videos like this to explain them more. Thanks, and see you again Monday for our next regular installment.